Welcome back, everyone. In this lecture, we're going to discuss a few built-in functions and operator keywords in Python that didn't really fit well into any of the previous categories. However, they're still really important and they're going to really enhance your ability to program with Python. Let's open up a Jupyter Notebook and quickly run through these. Let's begin by talking about the range function in Python. Notice that often we were creating lists that were just a series of integers, such as 1, 2, 3, or 1, 2, 3, 4, 5, etc., all the way up to 10. Because this is such a common task, Python actually has a built-in operator for this, and there's two ways you can use it. One is you can iterate through it, so I can say something like for num in, and then we use the keyword range, and it takes a couple of parameters. You can do Shift Tab here to see the parameters it takes, but basically it has a start, stop, and optional step size. So start is technically also optional. Let's show you how we can actually use these. So if we just indicate a single number, such as 10, and we say print num in range 10, what it's going to do is it's going to generate the numbers from 0 all the way up to but not including 10. So that all the way up to but not including, that's very similar to that slicing syntax we saw earlier in the course. So for num in range to 10, print number, and here we see 0 through 9. Now let's say we wanted to actually specify a starting index position for the integers. We could say start at 3, go all the way up to but not including 10, and then when we run this, we get 3, and then all the way up to, but not including 10. So that's the range operator. And in addition to all this, we can actually have a step size as well. So we can add a third argument for step size, and that gives us the even numbers. So that's taking jumps in steps of 2 from 0 all the way up to, but not including 10. So if we wanted to include 10 as one of those numbers, we'd have to put in 11 there, and then we get back 0, 2, 4, 6, 8, 10. So that's how you can use the range function for iteration. But you'll notice if I copy and paste this into a cell and ask for it to be returned to me, I just get back this range operator. And it's because it's a generator. So if I actually want the actual list of numbers, what I can do is cast it to a list, and then I get back the list of numbers. Later on in the course, we're going to discuss generators in a lot more detail, but basically a generator is just a special type of function that will generate information instead of saving it all to memory. So this is a more efficient way of generating these numbers instead of having a giant list stored in memory. And we'll discuss that in a lot more detail in the generators section of the course. Let's move on to discussing another really useful function called enumerate. And to show you the use case and motivation behind enumerate, let's do an example. I'm going to set a variable called index count equal to 0. Let me zoom in here at one level. So I have index count is equal to 0, and then for letter in the string A, B, C, D, E, I'm going to do some printing here. I'm going to say at index, the letter is curly braces. And then I will use dot format here to say index count and then the letter as well. Okay, so what I'm doing here is at index count, the letter is blank. And then what I will do is say index count plus equals 1. So when I run this, it says back the following information. At index 0, the letter is A. Index 1, letters B, and so on all the way until the end. Now this is such a common operation that what we're going to do is use the enumerate function to replicate this. And the reason this is very common is because a lot of times you will want to have some sort of counter for how many times have you gone through this for loop, or what index position you are at in this particular string. And the reason for that is because often people like to do something like this. They like to, let's define word as A, B, C, D, E, and then say for letter in word, print word at that index count. And then we say index count plus equals 1. So what's actually happening in this loop? Well, we're doing the following. We have an index count starts at 0, and we have a word string A, B, C, D, E. Then for every letter in that word, so for every character here, what we end up doing is we print the index value location at that word. And that's the same thing as printing the letter. But oftentimes what we'll end up doing is using this sort of syntax with a list later on in our code. But in order to do this, we need to have some sort of running index count. So when I run this, I get back A, B, C, D, E. Because this sort of operation is really common later on, what Python did is they built in the enumerate function. So let's see what happens when we use enumerate. So I'm going to delete index count here, and I will say for item in enumerate word, print out the item. And now when I run this, I get back, notice, tuples. So 0 with A, 1 with B, 2 with C. So this is basically doing that index count for us automatically in the form of tuples. And as we know, we have tuple unpacking from the for loop lecture, so I could say the following. I could say index, comma, letter, and then I could print out the index, and then print out the letter separately, and then print out a new line using an escape sequence character. So now I say 0A, 1B, 2C, etc., and so on. So this is the enumerate function, and it can take in any iterable object, and what it does is it returns back some sort of index counter and then the object itself, or the element at that particular iteration. The next one I want to show you is the zip function, which is kind of almost like an opposite of enumerate. What it does is it zips together two lists. So I'll say my list 1 is equal to 1, 2, 3, 4, 5. And I'm going to make my list 2 equal to A, B, C, D. Actually, let's just do A, B, C, 1, 2, 3. That way they match up. And then what I will do here is I will zip them together using the zip function. Now, if I just run zip, I don't get back anything. It just says, hey, you have this zip generator waiting for you at this location in your memory. If we actually iterate through it, so if I say for item in zip my list, and then I print out the item, notice back we get back this list of tuples. So previously in that for loop lecture, I mentioned that tuple unpacking is going to be a really useful thing because a lot of built-in functions in Python return back a list of tuples, and this is one such function. The zip function will, just like a zipper on a jacket, zip together these two lists and pair up these items so that they match together. And you can actually do this with more than just two lists. So I could say my list 3, and let's set this equal to some digits here. We'll say 100, 200, 300, and I could pass in this as another thing, my list 3, and now I can see the output is these tuples of 3 items. A common question is what happens if these lists are uneven? Well, we can check that. Let's add in a bunch more elements to the first list. So we're going to say 4, 5, 6 here. Now when we run this, we actually get back the same results. So keep in mind, zip is only going to be able to go and zip together as far as the list, which is the shortest. So it won't give an error, it'll just ignore everything else that's extra. You see here that we iterated through the zip, but if you actually just want to get the list itself, you can just cast it using list. So we can say list of zip, and then we'll put these lists together. And there you go, 1A, 2B, 3C. All right, that's the zip operator, very useful for zipping together two lists if you want to later use them together using tuple unpacking. So as I mentioned, you could unpack these. So I could say A, comma, B, comma, C, and maybe just print out B here, and I only get back the letters. Now I want to show you the in operator. We've already seen the in keyword during the for loop, but we can use it to quickly check if an object is in a list. I can say is X in the list 1, 2, 3, and it will return back a Boolean, true or false. Is it in 1, 2, 3? I could also use it for a list of letters. So for example, let's now say X, Y, Z. And now it returns true because X is in that list. So this is a really nice way to quickly check if something is in a list. So now let's change this to 2 in 1, 2, 3, and it gets back true. The in keyword, it also works on other iterable object types, so it works in strings as well. You can say is A in a world, and it returns back true. This also works in dictionaries as well for their keys. So I could say my key, and then check if it's in a dictionary. Let's quickly create one that has that key, my key, and let's give it some value, 345, and it returns back true because my key is in this dictionary. If you wanted to check if it's in items or if it's in the values, then you could just call that itself. So to show you what I mean by that, let's get back this dictionary. And then I could say, hey, is 345 in d dot values? It returns back true. If I asked for keys, it returns back false. So that's the in keyword operator. Very useful for quickly checking. I like to use it a lot when working with strings. A few more that I want to show you is some mathematical functions, min, max, and then the random library. So if you ever have a string of numbers, let's quickly create one. My list, 10, 20, 30, 40, and let's go jump to 100. If I ever wanted to know the minimum value there, there's a built-in min function that I could pass in, and it reports back the minimum of the list. And there's also a max function that reports back the maximum value of a list. So keep that in mind, because often it's going to be very tempting to use min and max as keywords, but they're already built-in functions in Python, so you should not use those. And that's denoted by the fact that they show you syntax highlighting there. Okay, let's quickly discuss the random library. So Python actually comes with its built-in random library, and there's a ton of functions included in this library. And this is actually going to be our first example of importing a library. So to import functions from a library, what you can do is say from random import, and if you hit tab here, you should be able to see a big drop-down list of options, and a lot of these are the functions that are available to you inside this particular built-in library. So the one we're going to show you right now is shuffle. So what this is saying is, hey, from that random library that's built into Python, import the shuffle function. And later on in this course, we'll discuss how to download other libraries from the internet. But for right now, random's built in. So now we have this shuffle function, and what it does is it randomly shuffles around any sort of list. So let's create another list, and let's make it in order. So 3, 4, 5, 6, 7, 8, 9, 10. And if we shuffle this list and then call the list again, it's now shuffled or scrambled. And if we run this shuffle again, so notice here I'm going to run that one more time, it's going to reshuffle the list. You should also note that it's actually not returning anything. So if I asked for this, random list is equal to shuffle, that's not going to work because it's not returning anything. So it's going to just say, hey, there's nothing there. And if you check out the type of this, it again says none type. So this is an in-place function, meaning it operates in place on that list. So if I check out my list, now it's still scrambled. Okay, so that's my list, and that's the shuffle function for shuffling a list. There's also a really nice function for grabbing a random integer. So we can say from random import rand int, and that allows us to quickly grab a random integer. So I will say rand int, and what we do here is we pass in a lower range and a upper range. So I can say rand int from 0 to 100, and it returns back some random integer. And if I do this again, from 0 to 100, another random integer. And most likely your numbers will be different than mine because, again, it's random. And because this is returning something, I can save it. So I can say my num is equal to rand int, 0 to 10, and then I can later on use that number. Finally, let's show you how to accept user input, and it's actually quite easy with the input function. So we use the special keyword input function, and then we have the text that wants to show up when we actually ask the user for input. So I'll say, hey, enter a number here, colon space, and when you run this, now Python's asking you to enter a number. So we'll go ahead and enter one. We'll say 50, and there we go. Now it has 50. Typically what you're going to do is save this as some sort of result. So you'll say, hey, whatever variable you want is equal to input. And this phrase, you can say whatever you want. So we could say, what is your name? We run this, and then it says, what's your name? I'll type in Jose. And then later on in your code, what you can do is refer to result, and we get back Jose as a string. So that's the basics of input. The thing you got to watch out for is that input always accepts anything that's passed into it as a string. So let's go back to that number example. So we'll ask the user, hey, what's your favorite number? When we run that, if I pass in 30 and I hit enter there, and then I ask for the result, it's actually the string version of 30. So if I say type of result here, it says, hey, it's a string. So in order to actually cast this, or really transform it into another data type, what I need to do is say either float of result to get back 30.0, or if I still want it to be an integer, I can say integer result, and it returns back 30. And now it's an actual number instead of a string, because if you just say result, notice here it still has those quotes. So keep that in mind. Input always accepts things as a string, because later on you may want to be using input for grabbing an index position, so you will most likely have to cast it. And you can do this all in one line by saying wrap this in int, and then we will get a favorite number here. So I say 20, and now when I check the type of my result, it's an integer. Okay, so that's the basics of the input function. And those are some other useful operators that we'll be using, especially later on in your first milestone project. You can check out the notebook for more examples, and I will see you at the next lecture. Thanks, everyone.